Okay, so we're going to be looking at vectors and we're going to be looking at how to add vectors that are in the same dimension, but we're also going to be looking at how to add vectors that are in two different dimensions, like the x and y, because we're getting into two-dimensional motion. So with vectors, remember they describe both magnitude and direction. Okay, and we've looked at several vectors so far. We've looked at velocity vectors, displacement vectors, and acceleration vectors. And we're going to look at more vectors. We're going to look at force vectors and momentum vectors and impulse vectors and electrical force vectors and magnetic force vectors. So vectors is a reoccurring theme in physics, okay? So physical quantity that has both direction and magnitude, whereas a scalar only describes how big the magnitude of the object or the magnitude of that quantity. So with scalar quantities, we've looked at speed, distance, time, mass. Those are all scalar quantities. So we know that vectors include magnitude and direction. So remember, magnitude here is just the size, or basically it's the numerical value. The numerical value. If I say we have a displacement of 15 meters east, remember 15 meters is the magnitude, whereas east represents the direction. Okay, so the magnitude is how big, the size of that displacement, whereas direction is the alignment or orientation. Okay, now if you've ever seen Despicable Me, there's this villain called Vector. Okay, and he says we represent vectors with arrows, right? With arrows. So that's how we're going to represent the vectors. The length of the arrow here represents the magnitude, how big the vector is, okay? And then the direction it's pointing in obviously represents the direction. So the bigger the arrow, the bigger the magnitude, okay? So this would be like if we walk 10 meters east, this would be like if we walk 20 meters east, okay? So the length of the arrow represents the magnitude. When we're adding vectors, and we're going to add vectors mathematically and graphically. Right now, we're going to focus on the graphical method of adding vectors. And for the graphical method, you're going to use a ruler and a protractor. So if you have those at home, bring those in, okay? But when adding vectors, you have to make sure that first the vectors have the same units. You can't add a velocity vector in kilometers per hour to a velocity vector that's in meters per second. So you have to make sure that the vectors have the same units. Another thing about the vectors, they have to describe, when adding them, they have to describe similar quantities. Okay, you can't add a velocity vector to a displacement vector, and you can't add a force vector to a velocity vector. Okay, so the vectors have to describe similar quantities and they have to have the same units. The answer found when adding two or more vectors is known as the resultant vector. Okay, we're going to look at that here in just a minute. So we're going to add these two vectors. Now, notice these vectors are in the same dimension. Okay, they're both in the x dimension. And again, the result of adding these two vectors is going to be known as the resultant here. Resultant. So we have vector A that has a magnitude of 3. So there's vector A right there. And we have vector B that has a magnitude of 2 units. Okay, we're going to add these two vectors together. That right here represents our resultant vector, which is 5 units to the right. So A is to the right, B is to the right. We're going to add those two vectors together. Now, I will say, when adding those vectors, we're going to take the tip of A, and then to that, we're going to add the tail of B. And so our resultant vector is going to go from the tail of A to the tip of B. So that would be our resultant vector there, which is 5 units to the right. Okay, so that's adding vectors, and that would be like vector A plus vector B equals our resultant vector. Now, what if we did vector A minus vector B? When subtracting vectors, the easiest way to think of this is to add the negative vector. So when we have a negative vector, the difference is that the direction of the arrow is in exactly like 180 degrees or exactly opposite to the direction it was originally. So here we have vector A, and then vector B, negative vector B, okay, is to the left instead of to the right, and then this represents our resultant. So we're going to take vector A. Now watch this. We're going to put the tail of vector B. So there's vector A, there's vector B. We're going to put the tail of vector B at the tip of vector A, and then this guy right here, going from the tail of A to the tip of B, this represents our resultant vector. So if this is 3 units and this is 2 units but to the left, this is going to be positive 1 unit to the right. Okay. So that's vectors in a single dimension. Okay, and notice we're adding them tip to tail, which we're going to look at here in just a second. So when we add vectors, we're going to use the tip to tail method. Okay, notice this is the tail of A, this is the tip of A, this is the tail of B, and the tip of B. Okay, so now we're looking at vectors that are in 2 different dimensions, and we're going to add them tip to tail. Okay, so what we're going to do here is we are going to move, so there's vector B, we are going to move vector B, we're going to take its tail, and so vector A, its tip is at the tail of vector B. So that's what I mean, tip of A to the tail of B. Tip of A here, tip of A to the tail of B. That's how we're going to add the vectors. And then the resultant vector is going to go from the tail of the first to the tip of the second. So the resultant vector goes from the tail of the first vector to the tip of the last vector. And so this right here represents our resultant. And again, these vectors are in 2 different dimensions. So we're going to take the tip of A and attach the tail of B, tip to tail, adding those vectors tip to tail. And then here the resultant vector will go from the tail of A to the tip of B. Okay. Now, same thing here. If we want to take A minus B, that's the same thing as taking A plus a negative B. Okay, so what we're going to do, is we're going to flip B around. Okay, so we're going to rotate B a whole 180 degrees, or in the opposite direction. So now what we're going to do is we're going to move, goodness gracious, we're going to move vector B so that, again, we're adding tip to tail. So we have the tip of A and the tail of B. Okay, so we're adding tip to tail, A to B. So this is B. And then the resultant vector will start at the tail of A and end at the tip of B. So the resultant vector looks a little different because we're taking A minus B versus A plus B. Okay? And we'll look at more of this later too. So properties of vectors. One, vectors can be moved parallel to themselves in a diagram. Okay, so you can move vectors around as long as you don't change their magnitude or length or their direction. So let's say I've got this vector right here. And notice we're taking the velocity of the car in meters per second, and we're adding the vector, the velocity of the walkway in meters per second. So we have like vectors, same unit, so we can add them together. Okay, now they are added tip of this one to the tail of this one. But I want to move this vector around. So if I take this vector, I can move it right here. Notice it's still tip right here. It's still tip of this one to the tail of this one. And then my resultant vector would look like this. So I can move vectors, and you can see this resultant looks very similar to this resultant. So you can move vectors around as long as you move them parallel to themselves. Okay. Property 2 is vectors can be added in any order. So if you notice here, we have 1, 2, 3, 4, 5 displacement vectors. Okay. And here's our resultant displacement from start to finish, a straight line from start to finish. And then they've taken those same 5 vectors and they've added them in a different order, and notice the resultant vector is exactly the same. Okay, so the order of addition doesn't matter. Okay, you can add vectors in any order, property 2, and then you can move vectors around parallel to themselves. And notice we're adding the tip of this one to the tail of this one, and the tip of this one to the tail. So we're adding tip to tail. The resultant here goes from the tail of the first vector to the tip of the last vector. Okay, the next video I am going to add vectors graphically. Add vectors graphically. Here are the steps. Okay, step 1 is, first of all, you need to make sure that you're adding similar vectors, velocity vectors to velocity vectors, and you need to make sure that you're adding vectors that have the same units. Okay, and we can add them, they can be in 1 dimension, we can add them that way, or 2 dimensions. Okay, so first thing is you have to define a scale, or you have to determine a scale. So that's step 1. Okay, the next step is you have to draw the vectors to scale using a ruler, okay, which is really hard to do on the iPad. Okay, and then you need to make sure you're adding tip to tail here, tip to tail, okay, and then you need to draw the resultant vector, and remember the resultant vector starts at the tail of the first vector and goes to the tip of the last vector. Okay, so you draw the resultant vector, and then you need to measure the length of the resultant vector, and that tells you the magnitude of the resultant vector. And then you need to use a protractor to determine the direction. And that says directionally. Okay, so those are the steps of adding vectors graphically, and I'm going to show you a problem in the next video.